Howdy folks, this is Mr. Ryan here, and I'm going to explain a really easy concept to you called the Rational Root Theorem. This is one of three very important theorems that can help you to solve polynomial equations. Okay? Now you already know how to solve a quadratic equation, which is a second power polynomial equation. You can factor or use the quadratic formula. Linear equations, those are easy. That's a first power polynomial. They're easy to solve. But when you start to get to the third power or fourth power or fifth power, it starts to become a little challenging if you don't have technology, a little challenging to solve for the zeros of these polynomials. Okay? So there are three theorems: the rational root theorem, the remainder theorem, and the factor theorem, that if you know all three of these theorems, you have a better chance of solving a polynomial equation. Now, in order to understand the rational root theorem, I want to first explain what does rational mean and what does root mean, just to make sure that you're aware of these two things. You should already know what these two words mean in terms of numbers, but I'm going to explain it anyways. A rational number is any number that can be represented as a fraction, which also includes whole numbers. Okay? So for example, the number 2/5 is a rational number, because remember that rational means fractional. That's what rational means. Rational means fractional. So anything that can be represented as a fraction is a rational number. So 2/5, that's a rational number. 6/1 is a rational number, although we know that 6/1 is equal to 6. Also, 10/5 is a rational number, but 10/5 can also be written as 2. And therefore, whole numbers are rational numbers. Integers, -3, let's say we got -12/4. Well, that's the same thing as -3, right? So even negative values can be rational numbers. Okay, so we've got so that's what a rational number is. Well, what's an irrational number? Irrational numbers are numbers that cannot be represented as a fraction without their symbol. Well, here, let me explain. The square root of 7. All right, the idea here is this: is rational or irrational numbers, if you were to punch them in a calculator, you would get lots of numbers after the decimal point. And they would only show you, the calculator would only show you like 8 of them, but the truth is, with the irrational numbers, those decimal values go on through eternity. So the number square root of 7 is an irrational number because it cannot be represented as a fraction without the square root symbol. Because you might say, well, hey, Mr. Ryan, the square root of 7/1, that's represented as a fraction. No, what I mean is this: that if you were to not use the radical symbol, you could not represent the square root of 7, which is somewhere between 2 and 3. You cannot represent the value of the square root of 7 as a fraction. Okay, so another number is pi. Okay, pi is an irrational number. Its decimal goes on to infinity. There is no finite, it's a finite value, but there is no finite end to the decimal values on pi. Okay, so we're only dealing with rational numbers here. Okay, when you use the quadratic formula, sometimes your answer comes out to be something like 2 plus or minus the square root of 13 over 7. I don't know, just making stuff up here, right? This is not a rational number. This is an irrational number. And oftentimes, the values, the answers, the solutions that we get from the quadratic formula are irrational numbers. In fact, that's oftentimes why the quadratic formula is so useful, because it works even when our theorems here don't work. So, we're dealing with numbers that are either whole numbers or easy fractions. Okay, so that's the rational root theorem. Well, what is a root? A root is simply a solution to the x value of a polynomial. Okay, so when we have x squared minus 7x plus 10 equals 0, there are two values for x that would make this true. So any solution for x that would solve a quadratic equation when it's equal to, or a quadratic function when it is equal to 0 is called a root. Okay, so a root, it's also the same thing as an x-intercept. A root is the same thing as an x-intercept. It's also called a zero. Sometimes we use the phrase zero. The zeros of the function, okay, are also the roots of the function, are also the x-intercepts of the function. These are all the same thing. So what we're looking for here is this. The rational root theorem is a theorem that will tell you all of the possible answers to a polynomial function if those answers are rational. So if the roots of a function are not, or if the roots of a function are not rational numbers, then the rational root theorem will not reveal those answers. Okay? So anyway, I'm going to show you this is sort of an investigative technique, a way of breaking down a polynomial so that you can solve it and find all of the possible answers to a polynomial. You have to know this is a very, very great technique. It's also really simple. Here's what you're going to do. The rational root theorem, it's going to show you how to, or if you apply it properly, you will make a list of all of the possible roots of a polynomial. And here's how it goes. We call so let's say we have some polynomial. Ignore these two for a minute. Let's just work on this one right here. 4x cubed minus 19x squared plus 19x plus 6. We only care about two things in this equation. We care about the lead coefficient, the lead number, and the constant at the end, the last number. You can ignore everything else in this polynomial. All we care about is the number at the front and the number at the back. Okay? Now, the number at the back breaks down into what we call the p's. And the number at the front breaks down into what we call the q's. So one of the ways we represent the rational root theorem is we use the letter p and the letter q. And here's what we do. We identify all of the factors of the last number, the numbers that multiply to get that number, all the factors of that number, and all the factors of the number at the front. And we ignore the sign just temporarily. And then we create a bunch of fractions out of those two numbers. Here's what I mean. So here we go. Let's say I want to identify all of the possible rational roots. These aren't all the rational roots. These are the possible rational roots of this polynomial. Well, I'm going to take all the factors of the last number. So I'm going to take the number 6. What are the factors of 6? What can be multiplied to equal 6? Well, there's 1 and 6, right? 1 and 6. And then there's also 2 and 3. Okay? So the factors of 6 are 1, 6, 2, and 3. Those are the only whole number factors of 6. We're going to do the same thing to 4. Okay, well, what are all the whole number factors of 4? Well, 1 times 4 is equal to 4, and 2 times 2 is equal to 4. So we're just going to put a 2. All right? So these are all the whole number factors of 6. These are all the whole number factors of 4. The numbers at the end, those are called the p's, and the numbers from the factors from the number at the beginning, those are called the q's. And then here's what we're going to do. We're going to put all of these numbers over all of these numbers one at a time. Here's what I mean by that. So we're going to do P over Q, all right, is equal to, all right. What's the first P? That's a 1, right? Over the first Q, 1. So we're going to do 1 over 1. 1 over 1. Then we're going to do the next p over the same q. Then we're going to do 6 over 1, comma, 6 over 1. Then we're going to do the next p, which is 2, 2 over 1, comma, 2 over 1. Then the next p, 3, 3 over 1, comma, 3 over 1. Now, 1 over 1 is actually 1. So instead of putting 1 over 1, I can just write 1. 6 over 1 is just 6. 2 over 1, well, that's just 2. And 3 over 1, that's just 3, right? And then the last thing. Now, we're not done. We still have to go through all these other q's. We have to do 1 over 4, 6 over 4, 2 over 4, 3 over 4. Then we have to do 1 over 2, 6 over 2, 2 over 2, and 3 over 2. Those are all of the rational roots, or all of the possible rational roots. Now, here's what I'm saying, though, is we don't just do 1, 6, 2, and 3. For every possible rational root, you have to do plus or minus. So we're going to put plus or minus 1, which means one of the possible rational roots is positive 1. One of the positive rational or possible rational roots is negative 1. Plus or minus 6, plus or minus 2, plus or minus 3. All right? Now, let's do, so we finished up with 1, now we're going to go on to 6. We finished up with 1 over here as the top of the the bottom of the fraction as the denominator. Now we're going to do all of these numbers over, let's do 2 next. 1 over 2 is plus or minus 1/2. 6 over 2, well, 6 over 2 is 3, right? So we would do plus or minus 6 over 2, except look, we already have plus or minus 3. We don't have to write it again, so I'm not going to write that one again. I mean, you can write it again if you really want to, fine, write plus or minus 6 over 2. But I'm not going to write it again because I already wrote it. Now I'm going to do 2 over 2, plus or minus 2 over 2. Well, what's 2 over 2? Isn't that 1? So plus or minus 2 over 2 is plus or minus 1, which I've already written, so I don't have to write it again. Now we're going to do 3 over 2. So plus or minus 3 over 2. All right, we're done with 2. Now we're going to put all these numbers over 4. 1 over 4. So plus or minus 1/4. 6 over 4. Well, 6 over 4 is the same thing as 3 over 2. And we already put 3 over 2, so we're not going to write it again. Then 2 over 4. Well, 2 over 4 is the same as 1/2, and so we don't have to write that again. And then 3 over 4. We haven't written that one yet, so we're going to put plus or minus 3 over 4. So this is the list of all of the possible rational roots. There's 2, 4, 6, 8, 10, 12, 14, 16 possible rational roots. And we're done. That's how you use the rational root theorem. Now we're going to do that same thing, only we're going to do it to this next problem here. In fact, why don't you try it? Why don't you pause the video in a minute? Let's erase this one. Take this one. 5x cubed plus 17x squared minus 37x plus 15. Remember, you only need the 5 and the 15. You don't need the rest of that in the middle. Pause the video and see if you can find the possible rational roots. All right, so we're going to take 15, the number that's at the end, that's the p's. Those are the ones that go on the top. The number at the beginning, the 5, those are the q's. Those are the numbers that go on the bottom. Well, what are all the factors of 15? 1, 3, 5, and 15. And what are all the factors of 5? Well, just 1 and 5. So, the p's over q's are going to be 1 over 1, which is plus or minus 1. 3 over 1, which is plus or minus 3. 5 over 1, which is plus or minus 5. 15 over 1, which is plus or minus 15. Right? All right, we're done with 1. Now we're going to go over 5. We're about halfway done. 1 over 5, so plus or minus 1/5. 3 over 5, plus or minus 3/5. And then 5 over 5, well, that's 1, and we already wrote that here. 15 over 5, that's 3, and we already wrote that here. So we're done. That's all of our possible rational roots. Okay? All right, last one. Try this one right here. So erase this. All right, erase this. And see if you can identify, pause the video, and see if you can figure out all of the possible rational roots of this. Remember, our number at the front is 3, and our number at the end is 14. All right, so let's see if you got them right. The number at the end, 14, those are the P's. The number at the beginning, 3, those are the Q's. Okay, so the factors of 14 are 1, 2, 7, and 14. The factors of 3 are just 1 and 3. And so our P's over Q's are going to be 1 over 1 is 1, so that's plus or minus 1. 2 over 1 is 2, so that's plus or minus 2. 7 over 1, that's 7, so that's plus or minus 7. And then 14 over 1, that's plus or minus 14. Now we're going to do the same 4 numbers, but over 3. So we'll have 1 over 3, that's 1/3, plus or minus 1/3. 2 over 3, that's plus or minus 2/3. 7 over 3, that's plus or minus 7/3. And lastly, 14 over 3, plus or minus 14/3, or 14 over 3. And those are all of the possible rational roots. That is the rational root theorem. It at first may have seemed a little confusing, but after you do this for a while, after you practice a lot, you'll understand. And that's all you have to know for the rational root theorem.